What if I told you that two spacesuits designed by engineers in 2024 for the same company, NASA, look absolutely nothing alike? On one side, SpaceX's sleek black fabric-based EVA suit that completed the world's first commercial spacewalk in September 2024. On the other, Axiom's white, Prada-designed Axiom-U moon suit tested underwater in July 2025, built like a tank with 8-hour life support. Both cost millions. Both keep you alive in space. But the designs are polar opposites. How can that be? Let me show you just how different these suits really are. The SpaceX EVA suit weighs significantly less, uses soft fabric joints that stay flexible until pressurized, features a 3D printed helmet with a heads-up display, and costs a fraction of traditional suits. It's designed for maybe 2-hour EVAS in low Earth orbit. It requires the entire Dragon capsule to be depressurized and relies on Starlink for communications. The Axiom-U? It's a completely different beast. It has a rigid life support backpack, operates independently for 8 hours, can withstand lunar South Pole temperatures ranging from 260 degrees Fahrenheit in sunlight to negative 280 degrees Fahrenheit in permanent shadow for at least 2 hours, features 24-karat gold-coated Oakley visors, and includes 4G/LTE communications. It's built to let astronauts kneel, crouch, and pick up rocks, something Apollo astronauts struggled with. But here's what blows my mind. Both suits are being developed under NASA contracts. NASA is paying for both. And yet, they represent fundamentally opposing philosophies about how humans should work in space. One prioritizes simplicity and cost. The other prioritizes capability and safety margins. And so which approach is right? And what does this tell us about the future of space exploration? Before we understand why these suits are so different, you need to understand the challenge they're solving. A spacesuit is basically a personal spacecraft. It must provide pressure, oxygen, temperature control, radiation protection, and communications, all while allowing the wearer to move and work. But here's where things diverge. The mission requirements are completely different. SpaceX's EVA suit is designed for Crew Dragon missions. Dragon is a 4-meter-wide capsule with no airlock. If you want to do a spacewalk, you depressurize the entire cabin. All 4 crew members must be in suits. The spacewalk duration is limited by how long you can safely expose the spacecraft's interior to vacuum. We're talking maybe 2 hours maximum, including decompression and recompression time. The suit doesn't need heavy-duty life support. It doesn't need to operate independently. It's essentially an upgraded version of SpaceX's Intravehicular Activity (IVA) suit, the black and white suit astronauts wear during launch and landing, enhanced to handle brief exposure to vacuum. Think of it like a diving wetsuit versus scuba gear. The SpaceX suit is the wetsuit. Protective, flexible, good for short dives. But you're not going deep or staying long. Now, the Axiom-U is solving a completely different problem. It's designed for lunar surface EVAs during NASA's Artemis 3 mission, scheduled for mid-2027. Astronauts will be exploring the lunar South Pole for up to 8 hours at a time. They'll be bending, kneeling, using geological tools, collecting samples, setting up experiments, and traversing rough terrain. The moon has no atmosphere. Temperatures swing wildly. There's razor-sharp regolith dust that can penetrate seals. Astronauts will be far from their spacecraft with no quick way to get back in an emergency. The suit must be completely self-sufficient. This is where things get strange, because these opposing requirements have led to radically different design philosophies. And understanding those philosophies reveals a fundamental debate happening right now about the future of human spaceflight. What I'm about to reveal will completely change how you think about spacesuit engineering. The story of how SpaceX and Axiom arrived at such different solutions, and what happened when these suits were actually tested, is full of surprising twists, engineering breakthroughs, and hints about where space exploration is headed. Hit that subscribe button because we're covering every major development in space technology as it happens, and trust me, the suit wars of 2024 to 2025 are just getting started. Let's start with SpaceX. The story begins in 2015, when Elon Musk revealed the first Crew Dragon spacesuit. It was dramatically different from anything NASA had used. Sleek, form-fitting, mostly black with white accents. It looked like something from a science fiction movie. But it wasn't just about aesthetics. SpaceX principal spacesuit engineer Eric Krauss explained in a 2024 video that the company approached suits differently. Instead of building rigid hard components with metal fittings, they used advanced textiles and 3D printed parts. The suit integrated directly with Dragon's seats, using an umbilical connection for air supply and cooling. The design philosophy was simple: mass producibility. SpaceX wanted suits that could be manufactured at scale, sized to fit anyone, and maintained easily. As a company planning to send millions of people to Mars someday, they couldn't rely on hand-built, one-of-a-kind suits. Then, in February 2022, billionaire Jared Isaacman, who'd commanded the all-civilian Inspiration 4 mission, announced the Polaris program. 3 missions. The first would feature the first commercial spacewalk, and SpaceX would need to upgrade their IVA suit into a true EVA suit. On May 4, 2024, SpaceX unveiled the result. The EVA suit looked remarkably similar to the IVA suit, but with critical enhancements. New joint designs using materials that stay soft until pressurized, a copper and indium tin oxide-coated visor to reflect sunlight and infrared heat, a heads-up display showing pressure, temperature, and humidity, improved thermal management, flame-resistant stretch fabric. But here's the key: it still had no backpack, no independent life support. It relied on Dragon's umbilical connection even during EVAS. On September 10, 2024, Polaris Dawn launched. On September 12, Jared Isaacman and SpaceX engineer Sarah Gillis opened Dragon's hatch at 740 kilometers altitude, higher than the International Space Station, higher than Hubble. They stepped out into the void wearing those suits. For the first time, 4 people were simultaneously exposed to vacuum. The spacewalk lasted about 2 hours, and it worked perfectly. Meanwhile, Axiom Space was on a completely different journey. In September 2022, NASA awarded them a $228 million contract to develop lunar spacesuits for Artemis 3. This was the first time NASA had outsourced spacesuit development to a commercial provider. Axiom inherited NASA's XEMU design, the Exploration Extravehicular Mobility Unit that NASA had spent $420 million developing between 2008 and 2021 with nothing to show for it. Axiom's job was to finish what NASA couldn't. Then, in October 2023, Axiom made a shocking announcement. They were partnering with Prada, the Italian luxury fashion brand, to design the suit's outer layers. Engineers and fashion designers working side by side. Prada would contribute expertise in advanced textiles, materials science, and manufacturing techniques developed for high-performance clothing. On October 16, 2024, at the International Astronautical Congress in Milan, the Axiom and Prada revealed the AxiomU flight design. It looked traditional, bulky, White outer layer, though the initial prototype wore dark gray for proprietary technology concealment. Blue-soled boots, reminiscent of Apollo. Attachment points for flags and mission patches. But the capabilities were anything but traditional. So how do these two suits actually differ? Let me break down the engineering. SpaceX EVA suit, the minimalist approach. At its core, this is a fabric suit with minimal hard components. The entire design relies on the principle that pressurized fabric can provide structure, like an inflated tire. When unpressurized, it's soft and pliable. When pressurized to 4.3 pounds per square inch with pure oxygen, the fabric becomes rigid. The joints use innovative soft designs that flex when pressurized while maintaining seal integrity. This is incredibly difficult to engineer. SpaceX developed new materials and fabrication processes specifically for this. The result? Greater flexibility than traditional hard-jointed suits. The 3D printed helmet is a masterpiece. Polycarbonate visor coated with copper and ITO to filter sunlight and reflect heat. A transparent heads-up display provides critical telemetry without obstructing vision. There's an integrated camera for documentation. Temperature control. The suit relies on ventilated air cooling pumped through internal channels. Simple, effective, but limited in duration. Total weight? Significantly less than traditional EVA suits. Cost? SpaceX hasn't disclosed exact figures, but industry estimates suggest under $2 million per suit, a fraction of NASA's $150 million EMU suits. The philosophy: make it manufacturable, to make it scalable. Accept some limitations in exchange for mass producibility. Axiom U. The capability maximizer. This suit is built completely differently. It features a rigid, portable life support system backpack containing primary oxygen tanks at over 1,000 pounds per square inch, a variable pressure regulator, the first new design in over 40 years, a regenerable CO2 scrubbing system, a water cooling loop with sublimator heat rejection, ventilation fans, 4G/LTE communications, biometric monitoring, onboard diagnostics, an HD camera system, and batteries for 8-hour operations. The suit body uses both soft and hard joints. Certain high-mobility areas like hips and shoulders employ bearing systems allowing rotation with minimal resistance. The design accommodates anyone from the 1st to 99th percentile of human body sizes, solving the sizing problem that plagued NASA for decades. The Oakley-designed visor system is extraordinary. A 2-part deployable visor for harsh lighting conditions, a secondary helmet bubble shield against UV radiation and dust, 24-karat gold coating to handle the intense sunlight at the lunar South Pole, high-definition optics technology for maximum visual clarity. The outer layer, designed by Prada, uses advanced materials selected for thermal performance, abrasion resistance, and dust mitigation. Prada brought expertise in flame-resistant fabrics and specialized sewing techniques developed for high-performance sportswear. Temperature management is robust, and the suit can withstand positive 260 degrees Fahrenheit in direct sunlight and negative 280 degrees Fahrenheit in permanent shadow for at least 2 hours. The liquid cooling garment underneath circulates chilled water through tubes against the skin. In the vacuum of space, a sublimator evaporates water to dump heat. Incredibly efficient. Total weight? With the backpack, considerably heavier than SpaceX's suit. Cost? Not publicly disclosed, but given NASA's development investment, likely $200 to $300 million per unit. The philosophy: maximum capability, maximum safety margins. Accept higher cost and complexity for mission-critical performance. But here's where the story takes an unexpected turn. Because when these suits were actually tested, something interesting happened. The SpaceX EVA suit performed flawlessly during Polaris Dawn in September 2024. Jared Isaacman and Sarah Gillis floated outside Dragon at 740 kilometers altitude, conducted mobility tests, and gathered critical data. The suits maintained pressure. The thermal systems worked. The mobility was excellent. Mission success. Critics had worried about the lack of a backpack. What if the umbilical fails? What if there's a micrometeorite strike on the spacecraft? But SpaceX's counter-argument was elegant. Dragon's cabin is the life support system. By depressurizing the whole spacecraft, you eliminate the single-point failure of a hatch seal. Everyone's in suits anyway. If something goes wrong, you're already inside the vehicle. Just close the hatch and repressurize. Then, in July 2025, Axiom's Axiom-U went through its own crucible. An astronaut Koichi Wakata, Axiom's chief technology officer and former JAXA astronaut, donned the suit and descended into NASA's Neutral Buoyancy Laboratory, a 40-foot-deep pool containing 6.2 million gallons of water that simulates microgravity. For 6 hours, Wakata tested the suit's mobility, planted an American flag on a submerged lunar surface, used geological tools, and performed complex maneuvers. 2 NASA spacesuit engineers also tested the suit. The results? Better than expected. The suit's advanced joints allowed movements impossible in previous designs. But there's controversy. Some engineers argue Axiom is overbuilding. Professor Pablo de Leon from North Dakota developed an experimental suit in 2006 operating at just 1 pound per square inch instead of 4.3 pounds per square inch. Lower pressure means dramatically better mobility at a fraction of the cost. And his prototype cost $100,000. NASA's response? Safety. At 4.3 pounds per square inch, there's a comfortable margin. At 1 pound per square inch, you're at the edge. Any leak becomes immediately life-threatening. And SpaceX is pursuing yet another approach. Their Starship vehicle will need its own specialized suits. Elon Musk has hinted that Starship crews might wear evolved versions of the current EVA suit. But for Mars missions lasting months? That's a completely different challenge requiring different solutions. The plot thickens when you consider Polaris 3, the third mission in Isaacman's program, will be the first crewed Starship flight. What suits will they wear? SpaceX EVA suits? Something new? Nobody knows yet. So here's what I genuinely want to know from you. Given everything we've covered, which spacesuit philosophy do you think is the future? Drop your vote in the comments. Option A, SpaceX minimalist approach. Lightweight, fabric-based, mass-producible suits with shorter duration capability. Option B, Axiom, maximum capability approach. Heavy-duty, long-duration suits with every safety margin and redundancy. Option C, hybrid approach. Different suit designs optimized for different missions. LEO versus Moon versus Mars. I'm genuinely curious what you think, because this debate is defining the next 50 years of human spaceflight. Your perspective matters. Maybe you'll identify an approach engineers haven't fully considered yet. The implications of these competing suit designs extend far beyond just engineering preferences. This is about the future of humanity in space. First, cost and accessibility. If SpaceX can mass-produce suits for under $2 million each, suddenly commercial spacewalks become economically viable. Space tourism companies can offer EVA experiences. Private space stations can have EVA capabilities without bankrupting themselves. The barrier to entry drops dramatically. Second, mission specialization. Maybe the future isn't one universal suit. Maybe we need different suits for different environments. Light suits for LEO station work, heavy-duty suits for planetary exploration, specialized suits for microgravity construction. This diversification could unlock new capabilities. Third, the Mars question. Both companies are ultimately designing with Mars in mind. SpaceX's scalable manufacturing approach makes sense if you need hundreds or thousands of suits for a Mars colony. But Axiom's robust life support and dust mitigation features address real Martian challenges: thin atmosphere, pervasive dust, extreme cold. Fourth, technology transfer. The innovations in both suits have Earth applications. SpaceX's advanced textiles and 3D-printed helmet components could revolutionize protective equipment for firefighters, hazmat workers, and deep-sea divers. Axiom's regenerable CO2 scrubbing and advanced thermal management systems are being studied for medical ventilators and climate-controlled clothing. And finally, this represents a fundamental shift in how space technology gets developed. NASA didn't build either of these suits. Commercial companies did, under contract. This competitive model is driving innovation faster than traditional government development ever could. But here's the hopeful part. Both approaches are working. SpaceX proved their minimalist design during Polaris Dawn's successful commercial spacewalk. Axiom's Axiom-U is passing every test, moving through critical design review in 2025, and on track for Artemis 3 in mid-2027. Competition is accelerating progress. When SpaceX demonstrated that EVAS don't require $150 million suits and massive airlocks, it challenged industry assumptions. When Axiom showed that commercial providers can deliver capability NASA couldn't, it validated the public-private partnership model, and both companies are learning from each other. SpaceX is studying Axiom's advanced life support for longer-duration missions. Axiom is examining SpaceX's manufacturing techniques to reduce costs. The Artemis 3 mission will put the first woman and first person of color on the Moon wearing Axiom-U suits. Future Polaris missions will continue refining SpaceX's design. And somewhere in between, the optimal solutions for different mission profiles will emerge. Science is making real, measurable progress. We're not choosing between these approaches. We're pursuing both, learning from both, and building a more capable and affordable space program because of both. But these aren't the only revolutionary spacesuits in development. There's Boeing's Starliner suit, with its distinctive blue design and unique cooling system. There's the Chinese Phaeton suit that's been used on Tiangong Station. And there's the question everyone should be asking. What will Starship crews wear to Mars? With Starship planning for 100 passenger flights to Mars, how do you build 100 specialized suits? How do you maintain them? How do you handle EVAs on a months-long journey? If you want to explore these questions with me, subscribe and hit that notification bell. The suit wars are just beginning, and the next few years will determine how humans work in space for the next century. Thank you for joining me on this deep dive into the spacesuit revolution. Whether you're Team SpaceX minimalism or Team Axiom capability, one thing is certain. We're witnessing a golden age of spacesuit innovation. Two radically different philosophies, both valid, both working, both pushing the boundaries of what's possible. The next time you see astronauts floating in Dragon or walking on the Moon, remember? They're wearing the result of fundamentally different visions for humanity's future in space. And honestly, we need both. Keep looking up. The future of space exploration is being stitched together right now, one suit at a time. See you in the next one.